Hello. So here we have an integral of x cubed plus x, all divided by x minus 1 dx. Now, since the degree of the numerator is greater than the degree of the denominator, we're going to have to divide first, and typically this is taught using, well, long division. I say screw using long division. How I'm going to divide this is just make a picture of x cubed plus x, doing this in a place value chart. I call it an x to 1 machine. So our boxes are just powers of x. So we have, this is our ones box, and then we have x, x1s make x, and x of those would make x squared, and then x of those would make x cubed. So we have one x cubed, so we have one dot in our x cubed box, and we have one x, so one x. And we're dividing by x minus 1. We're saying how many groups of x minus 1 do we see in our picture of x cubed plus x? What does x minus 1 look like? Now, x minus 1 is just going to be, well, it's going to be 1x, right? But that's going to be a minus 1. There's going to be an anti-dot or a Todd in the ones box. So we're looking for a dot next to a Todd. Now, we have one dot in the x cubed box. We could go ahead and put in a Todd in the x squared. It'd be really nice to have a Todd there, but we got to go ahead and put in a dot as well to counteract that, because a dot and a Todd together, well, they just go poof and they annihilate each other. And now we see we have one group right here, and it's always going to be, all the dots are going to reside at the rightmost part of the loop. So we have one group right here at the x squared level. Again, we have a dot. It would be nice to have a Todd right here. We got to put in a dot as well to counteract that. And then we see one more group at the x level. But now we have two dots in the x box. So we can go ahead and put in two Todds. We got to put in two dots as well to counteract that. And then we see two groups right here. So what do we have? We have 1x squared, 1x, but then, and then we have the two dots that are still waiting to be divided by x minus 1. So we can write our integral as the integral now of 1x squared, so we have x squared, plus x, plus 1 at the x box, and then we have 2 at the ones, so plus 2, but then we have plus 2 more dots, still waiting to be divided by x minus 1. And now this integral is going to be super simple to integrate. The integral of x squared is just we add 1 to the exponent and divide by that, so we get x cubed over 3, and then the integral of x is just going to be x squared over 2. The integral of 2 is just going to be 2x, and then the integral of 2 over x minus 1, that's just a simple u sub, letting u be equal to x minus 1, then du is dx, and the integral of 1 over u, or 1 over x, is the natural log of the absolute value of x. So in this case, we get plus 2 times the natural log of the absolute value of x minus 1, and then, of course, plus a constant. Calculator. Take care.